Okay, so welcome. We're going to be starting very shortly. I'm going to let people log in. Just give people 1 minute more. But we're going to work on vector addition.
Morning, sir.
Good morning. How are you? So I've already marked and posted your marks for the first assignment. So thank you to those of you who who worked on that and got that in. All right. So just a few housekeeping items first. So I am unwell this week, and as discussed, I'm going to ask that we take your class 701 on online tomorrow. Okay. And because of that, I'm going to be posting that recording for 401 and 402 as well. So Thursday, which is now, we'll have part one. And then Friday, tomorrow, 10:30 a.m., it'll be part two. And for 401 and 402, that recording will be posted. Okay. Now, since we're in a new week, it's probably a good idea to take a look at what assessments you're going to be dealing with this week or in the coming weeks. So based on the schedule of the course, assignment number 2 is going to be this week. So it's due on the 1st of June. But it's critical that you get your assignment done in such a way, or you understand your assignment in such a way that you're able to perform on the test. And so that puts me in a bit of a pickle. So I don't feel comfortable this is according to the course outline. I don't feel comfortable taking a test on stuff that you haven't been marked on before. So I've done this before, but I want your permission. I'm going to put up a poll, and I need your help here. Can we move test 1 back to week 6? Give you more time instead of week 5. So I'm going to be launching the poll. My vote is to push it back to week 6. Okay, so if you guys can take a look at the question, this will give you a chance to practice more and get my feedback on assignment number 2, because assignment number 1 and 2 are the basis for test number 1. Okay, so based on this poll, let's see. So we've got 7 out of 7 that have answered. 5 of you have not answered yet, so if you guys could go ahead and do so. So right now it's 9 out of 9 in favor of pushing it back to week 6. Okay, thank you. The problem with having your test in week 5, which I think is according to the original course outline, is that you will not receive the results of your assignment number or the feedback or your march for assignment number 2. And it's a big part of the test. Number 2. Okay, so thank you. We're going to push test 1 back to week 6, and we'll push assignment 3 back to week 7. That's how we're going to do this. And then the new professor will probably adjust the schedule for tests 2 and 3 and assignments 4 and 5 to make it more reasonable for you guys. So this is going to be changing. I'll post this by next week. But just to be firm, we are not having test 1 in week 5. We're going to continue to try to finish assignment number 2 and practice these vector questions. So what I'd like to now ask you to consider is, what are the steps? So you've got a vector, and you need to add it to another vector. So what are the steps to take? First, find x and y components. That's number 1. Number 2, add all x and y components separately. Then what I like to do is sketch the x and y legs of what is the resultant. What does that mean, the resultant? That when you add vectors, that's the resultant. And what you're getting is, when you add the x and y components, you're getting the x and y components of the resultant. And then you can use Pythagoras, find the magnitude, the resultant, and then the direction. So these are the key steps. But let's go ahead, and I'm just going to pull out an example from thin air, and hopefully that'll get us started in the right direction. Let's say you've got vector 25 degrees, and we'll call this F1, and it's equal to 10 newtons. And then you've got a vector F2, and it is equal to 5 newtons. You've got an angle here, it's 15 degrees. So what you want to do is work on them separately. That's what I would recommend. So maybe I'll use a different colored marker here. So maybe I'll work on this one first. F1. This is 10 F1x, F1y. This is 25 degrees. So sine of 25 is equal to F1y over 10. So F1y is equal to 10 times sine 25 degrees, which is equal to, so let's get out our calculators. I suggest that you practice actually performing your calculations, because if you are then trying to do this in the test and you get it wrong, well, it's a little bit too late then. So that's 4.226. 4.226. I'm going to put down 2, okay? And then F1x is equal to 10 cosine 25 degrees, which is equal to 25 cosine times 10. Let me know if I'm getting this wrong. 9.0630. Okay. Now here's what I like to do. I like to make a little box in the corner somewhere and note this down. Because when you have many of these, you end up having to look back and trying to find the right number. So F1x is equal to 9.0630. F1y is equal to 4.2262. Is that everything? No. Why? You need to put a minus here. Why? Because the y component of F1 is going downwards. If the x component of F1 is going in this direction, no need to put a minus. So that's the first. So let's work on the second one, F2. We'll use a different color. This is F2 equal to 5 newtons. It's 15 degrees. This is F2x, F2y. So sine of 15 degrees is equal to F2x over F2, which is 5. So F2x is equal to 5 times sine of 15 degrees. So sine of 15 times 5, 1.2940. It's equal to 1.2940. And F2y is equal to 5 cosine 15 degrees is equal to 4.8296. Hopefully I got this right. Let me know if I'm wrong. So F2y, 2x is equal to 1.2940. But here's the thing. It's in this direction, so put a negative. And F2y is equal to 4.8. I think that's 296. And that's also negative because it's in a downward direction. So now that we have these, what I'm going to do is to create space, I'm going to erase this so we can keep working. So let's add the x components. So that would be equal to, so we'll call it the x component resultant, Rx. Is it going to be equal to F1x plus F2x, which is equal to 9.063 plus minus 42262, which is equal to 9.0630 minus 4.2262, which is equal to so that's Rx. Now you do the same for the y components. Ry is equal to F1y plus F2y is equal to, so let's see, that will be minus 1.294 plus minus 4.8296 is equal to, so it's going to be in the negative, 4.8296 plus, so it's going to be minus 6.1236. So what does that mean? Your resultant, this is what it looks like. Let me get a different color for the resultant. Go back to red. Y, Ry, that's this. It's in the downward direction, so it's 6.1236. And our x is positive, so it's in this direction. This is 4.8368, which means the resultant will look more like this. We don't know the direction. We have y, we have x. So let me create room. So r, the magnitude r, we're going to look for that first. So it's r squared is going to be equal to 6.1236 squared plus 4.8368 squared. So r is going to be equal to, let's go ahead and calculate that, 37.4984 plus 23.3946 square root 60.8914 square root 7.8032 newtons. That is the resultant. Is that the complete answer? No. Why? You don't have the direction. So what you do is you basically get this as sine. So sine theta is equal to 6.1236 over 7.8032. And that way you can determine sine by using the inverse function. Okay. So that's what I want you guys to be very good at, or at least somewhat good at by the end of this week. Because that will put you in a better place for you moving forward. Let's now work on some slides. Actually, before I do that, does anybody have any questions? Thank you, Samantha. Thank you, Samira. Tomorrow, yeah, I'm still in a bit of recovery from the infection, so tomorrow it'll be just from home. It'll be very hard for me because it's the highlight of my week to come and see my ARAP students. It's like the best thing ever. Okay, so as this is a shorter class, I do want to get going. It's not really um it's not really hard what we're doing. It's just very time consuming. You have to go through the steps. And if you don't go about in the right process, it's very easy to make a mistake. Okay, so angles and slope are not really that important today. Am I even in the right spot? But yes, I am. So what we're trying to do is with these calculations, we're trying to calculate these loads, right? And sometimes it's on a slopes, sometimes it's at an angle. That's why we are calculating with using the components of the force. And this is where the vectors and scalars becomes important. Just to reiterate, a vector has a value, a magnitude, and it also has direction. Scalar does not. So for example, age is a scalar, heat is a scalar, speed is a scalar. On the other hand, acceleration, velocity, force, these are vectors. And that's what we're working with. Essentially, what we're trying to do is to break it down so that we can make a simple calculation based on vectors. Now, let's say we have vectors that are showing distance and direction. So we've got a man walks 54.5 meters east, then another 30 meters east again. And how would you calculate its displacement? The vector addition. In this case, it's easy. Why? Because they're both along the x-axis. There's no y component. You just add the two, and you get the answer. So it'll be 84.5 meters east is what the total displacement was. That's what we're trying to do. We're trying to break it down so that we're just adding vectors along one line. So I don't know if we have any Game of Thrones fans here, but this is how this person used to talk. It's one of the assassins. So let's continue. So if this case, if we're deducting it, the direction is in the opposite, then you're going to have only 24.5 as the net displacement. And when you have two vectors that are perpendicular, you just use the Pythagoras theorem and trigonometric functions. So in this case, you can get the resultant by calculating the magnitude and using the components to determine the direction. I like to draw my vectors head to toe or tail, head to tail. And what does that mean? I like to depict my vectors as an arrow, although my arrow, I like to have it shown in the middle, not so much at the end. And I like to use what is known as a triangle method. I like to create triangles. But this is known as the head to toe. And in a system where you've got north, south, east, west, depending on what kind of work I'm doing, I like to know in what quadrant my vector is. Northeast. And then this is how I would mention its direction. Although for you guys, it's probably not going to be that important, the direction. As long as you can configure which way's up and which way's down, especially when it comes to the moments. Like clockwise is negative and anti-clockwise is positive or so on. But this is how it's depicted. North of west or west of north, the angles. In this case, north of east is what the angle of the resultant is. And you can find theta by using the tangent function. So the opposite side in this case is 55. Tangent is equal to opposite over adjacent. Adjacent is 95. So theta will be 30 degrees. And this is the complete answer, magnitude and direction. But just imagine that this is exactly what we are doing. We are breaking down vectors into something that is tangible and easy to work with. And the reason why we use the displacement vector as an example is it's easier for us to imagine as opposed to force. So what if you're missing a component? What do we do then? Well, we can still find it. So let's say we've got this vector here, 65 meters, 25 degrees angle. Can we find the components? Yes. The vertical and the horizontal components should be quite straightforward. I think this might even be a test question, by the way. So make note. This is a test question, I think. So remember, cosine theta is equal to adjacent over hypotenuse. Sine theta, we remember, is equal to opposite over hypotenuse. And you can use that to determine the vertical and horizontal components, which are solved here in this slide. So I want to give you guys a few minutes to try to consider this question. We've got a bear, and it's searching for food. It wanders 35 meters east, then 20 meters north. Then the bear wanders another 12 meters west, then 6 meters south. Calculate the bear's displacement. So this is a good question for the people who I see on YouTube who say they'd rather run into a bear in the woods than a man. So this is a good question for people who are thinking about that. So here we've got the bear. And one of the good things about the man is I don't think he'd be wandering this strangely, but of course, this bear is searching for food. I personally would rather not run into a bear. Maybe not even a man. It depends on the man. So let's see what this gives us. So we've got 35 meters east, then 35 meters, 20 meters north. Then he wanders another 12 meters west, 6 meters south. And what is the resultant? We're going to be adding all of these together. So what you do is you first add all of the x components, which is what has been done here, and then you add all of the y components, which is what this solution is doing now. So now you got your x and y components of the resultant. This is essentially what I'm asking you to do for all kinds of vector additions. Write a resultant. Now you determine the magnitude. How do you do that? 14 squared plus 23 squared square root. Here's your answer. And then how you determine theta? The inverse tangent. There you've got your final answer. Okay. So I'll give you guys a minute or two to look at this and consider this question. So a boat moves with a velocity of 15 meters per second north in a river which flows with a velocity of 8 meters per second west. Calculate the boat's resultant velocity with respect to due north. Let's go ahead and do that. So the boat moves with a velocity of 15 meters per second due north. And the river is flowing 8 meters per second west. So in this case, all you have to do is calculate the resultant using Pythagorean theorem and getting the direction. Again, I think this is also a test question. So if you do not write the complete answer like this, your answer is not correct. Let's say, because you're not a cartography class and you don't want to know, oh, you're not sure it's at 28 meters north or south, or just show the angle and the answer, and I'll be good with that. Okay, because like I said, you're not in a surveying class or a mapping class, so it doesn't matter from this course point of view. Okay, so I'll give you guys a chance to work on this. A plane moves with a velocity of 63.5 meters per second at 32 degrees south of east. Calculate the plane's horizontal and vertical velocity components. So I'll give you guys 5 minutes to do this. Okay, so this is the solution. First, I would recommend that you sketch. Make a sketch. Got your horizontal component, your vertical component. And here is the answer. Hopefully. Now, this is for the actual questions you'll be working on. This is just the first step. Finding this. Okay, I'm going to continue past this. I think I've made my point. Use the solutions to help you if you have any confusion. Okay, so what we're trying to do is find the resultant. Right? You can have a graphical approach, a triangle approach. You can have different approaches. I like the triangles. I like to make the triangles. And some people also use the parallelogram or the polygon. I don't like those. I like to use the triangular method, right? And to get the resultant that way. So we've already gone through this a few times, but just a reminder of what vectors and scalars are. Why? Because If this is a brand new concept, it takes a little bit of time to grasp this. So I just wanted to make sure that you did. Another interesting aspect is vectors can be denoted with, bold letters in print, or some people put an arrow over it. I like to show, I like to show uh, it with an arrow on a sketch. Another thing is some people like to use Cartesian units to show the components. So I and J are the are the X and Y components. So you've got A vector. Its magnitude is 500. Its tail is shown here, and its direction, the top is the head. If you were to multiply a vector by a scalar, no issues. It just increases in magnitude. As you can see, direction is very important. So in this system right here, the vector, sorry, the vector's direction determines whether it's plus or minus. And convention is for the y components, always consider upwards plus, downwards minus. And to your left, negative for the x component, to your right, positive. You can then add vectors all working in a system. You can come up with a resultant by using the components. Like I said, I like the triangular method. So what I would do in this case is generate the x and y components of A, find out what the x and y components of the resultant are, and then determine what the magnitude and direction of the resultant are. Some people like to do it in a parallelogram. Again, this is not for me. You do it. It's your choice. If you get the right answer, no problems for me. So let's take a look at another example here. I'll first sketch it out, and then we'll work on it. So I just wanted to also mention that it's at this stage that if you are not understanding something, you do have to somehow either get tutoring or get extra help to figure this out, because this is now, we're getting into the real meat, or the potatoes of the course, the real key concepts. It's 30 degrees. It's 45 degrees. So what I'm going to do is try to solve this with you guys. Maybe I'll give you guys a few minutes to try to think about it, and then I'll solve it. And then you can, because if I just solve it, there is a chance that you're not getting it yourself. So I'm going to give you guys a minute or so, few minutes to try to solve it yourselves first, or start on it at least. Okay. So I'll refer to this as F1. So for F1, it's 50. That's this F1Y, F1X. It's 30 degrees. So sine of 30 degrees is equal to F1Y over 50. F1Y is equal to 50 times sine of 30. $25. And F1X is equal to 50 cosine 30. $43.30. All right. So as I had said earlier, save it, store it somewhere. F1X is equal to 43.30. F1Y is equal to 25. Now I'm going to work on the other vector. I'll say this is F2. So F2 F2X, F2Y. So F2Y is equal to 30 newtons times sine 45 degrees. It's equal to 21.213. F2X is equal to 30 times cosine 45 degrees is equal to it's exactly the same, except for one difference. Remember, this is the direction, so this is going to be minus. So now what we're going to do is we're going to add all the x and y components. So in the interest of time, I'm just going to keep going, although I would like to create a box over here. So the x component of the resultant, we'll use blue. It's going to be F1x plus F2x. F1x 43.30 minus 21.213. It's equal to 22.087. It's a positive, right? So Ry is going to be equal to 25 plus 21.213, 46.213. Let's use black. So Ry, 46.213. Rx, 22.087. Here's the R. So R squared is equal to 22.087 squared plus 46.213 squared. So R is going to be equal to 51.2198 newtons. And for direction, all you need to do is do the inverse tan of and that'll give you the angle. So that pretty much is what we need to work on this week. Any questions?
Hi, Professor. How long will the class tomorrow be?
Uh, so the actual class will be about an hour, and then there'll be uh, time for you to work on assignment two. And I'll give you hints and tips as you work along so that you can finish it quicker.
Okay, sounds good. Thank
Technically,
you.
in-class assignments, even though I am allowing for you to work on them at home at your convenience, and also because some of the sections are asynchronous, so in-class doesn't really work when you're not even in class and you're watching recordings. So I offer that option to both of you, but I do want you to get started. All right, I'm stopping the recording now so that it can download quickly so that I can post it to YouTube for sections 401 and 402. Tomorrow, because I'm meeting uh, only this week, 701 online, I'm just going to use the same recording for 401 and 402. So that should also be available to you guys tomorrow. Okay.